Chapter 5 was all about solving systems, so there were no specific formulas here, so that's kind of nice, just math. So we'll see if we remember that. So first one is graphing numbers on an inequality on a number line. So a greater than 3 and, so this one is the and, which means, if you remember, yeah, the overlap, good. Okay, so I'll put 3 on my number line and I'll put 12. Okay, greater than 3 is an open dot, less than or equal to 12 is a closed dot, and if I want numbers that are bigger than 3 and less than 12, that would be all of this middle area here. Awesome. Number 2 is D is less than -4, or D is greater than or equal to positive 6. So if we're thinking about this, this is kind of the combination. Okay, so it's both of them. So less than -4 would be out to the left, or greater than or equal to 6 is going to be out to the right. So you're going to have arrows pointing in both directions here. Just remember, if the equal sign is here, the greater than or equal to, the equal to tells you to fill in your circle there. If it's just less than and there's no line, then you keep it open. Okay, let's try 3. Solving. Okay, so let's maybe first get our x's together. So maybe we'll add 8x to each side. So we'll have 12 less than 36 plus 12x, and then subtract 36. So I'd have -24 less than 12x, divided by 2, -2 less than x. Okay, so just remember, we didn't have to do it in this one, but remember, if you multiply or divide by a negative, you have to flip the sign. So multiply or divide by negative, flip sign. Okay, you're definitely going to want to remember that for the exam. So I've got -2 less than x. So I'll put -2, maybe -4, and 0. Now, I think this is kind of hard to remember which way to do it. So I usually turn this into x greater than -2. Okay, so I have x on the left side. So you kind of just reflect it over, flip it over, and then x greater than -2 would be an open dot, and then graphed out to the right. Okay, if you have the x on the left side of the inequality, then this inequality sign just points to which way you shade. So it points to the right, so I shade to the right. Just a little trick for you. Number 4, describe the graph of a system with no solution. So if you remember systems, we were looking for the point of intersection. So if there were no solution, then those lines were parallel. Okay, if it was infinite solutions, that meant it was actually the exact same line. Okay, because they intersected everywhere. So let's try solving some of those. So number 6 is, how many solutions does this have? Okay, well, I don't know. Maybe you should graph that in your graphing calculator. Okay, see how many you get. If you graph it, you should get something like this for one of your graphs, and then the other one is like this. So tell me how many times they intersect. Once, twice, 3 times a lady. That's a song. So this answer is 3. Sorry, that was old school. Okay, so sometimes it just asks how many. Remember, you're looking for the points of intersection, so 3. Number 7 actually wants you to solve it, and we had a couple different methods. You could solve it by substitution or by elimination. Okay, this one is kind of set up for substitution because I have a y equals. So I'm going to take this and substitute it in for y in the bottom line. So I'll have 5x minus 2, but instead of y, I'm going to write 6x minus 2. That equals 18. From here, I can solve by distributing. So 5x minus 12x plus 4 equals 18. I'm just going to warn you right now, watch your negatives. -2 times -2 is a positive 4. Okay, 5x minus 12x is -7x plus 4 equals 18. Then subtract 4, -7x equals 14. Divide by -7, x equals -2. Again, please, please, please watch your negatives. Okay, now answers are ordered pairs. So to find the y coordinate, I'm going to plug it back into this very first equation over here. So I'll have y equals 6 times -2 minus 2, which will be -14. So my final answer is -2, -14. Okay, ordered pairs. Okay, let's try 8. It is kind of set up the same way. So I could substitute 7x in for y down here. So that would give me x times 7x equals 343. Just remember, x times 7x is 7x squared. is not that naughty. Okay, then remember that we should be dividing by 7 here first. So we should get x squared to equal 49 and then square root it. So x should equal, oh, please do remember this part. I know you're thinking that before I even wrote it, plus or minus 7. So we're actually going to have 2 ordered pairs here. We're going to have 7, 49 and negative 7, negative 49. Okay, 2 separate ordered pairs. And I got the 49 by plugging it in to that equation. Okay, good. Hopefully you remember these okay. You did well on these on that first exam review. Number 9 is set up a little bit more like linear combinations because here we have our x's in order, our pluses in order, our y's in order, our equals in order, and our numbers. But right now, nothing cancels out. So if I notice, I have 2y and 8y. And it would be kind of cool if that top one said 8y. So I'm going to multiply that whole top row by 4. So that's going to give me 16x plus 8y equals 56. And then I'll just rewrite this second equation without touching it. Okay, now the real trick is, do I add them or subtract them? Okay, well that's kind of up to you, but right now you want them to eliminate. And if you add 8 plus 8, they do not cross out. But if I do 8y minus 8y, they do. So we're going to subtract. Just watch your negatives. 16 minus negative 3 is a 19x. 56 minus 18 is 38. So x will equal 2. Okay, just watch your signs. Again, you've got 4 equations now. You can plug it into any one. I'll just pick this first equation. So I'll have 4 times 2 plus 2y to equal 14. So I've got 8 plus 2y equals 14. So 2y would equal 6. So y would equal 3. So my ordered pair would be 2, 3. Okay, so just make sure you plug it back in for the right variable, and then your ordered pairs are always x comma y. Okay, so number 10. Let's see, what would get things to cancel out here? Maybe a 3. So that'll give me 3x plus 6y equals 6. And then 3x plus 6y equals 6. Now at this point, some of you tend to just say, I don't know what to do. Okay, but go through the math. To actually get these to cancel, I would subtract, right? So 3 minus 3 is 0. 6 minus 6 is 0. And then 6 minus 6 is 0. So write it out till you get to that point. Because 0 equals 0 is a true statement. And a true statement is, final answer, infinite solutions. Very good. Okay, it will not always work out to be 0 equals 0. Sometimes you could get like a 0 equals a 15 when you subtract. That is false, which means your answer would be no solutions. Okay, so keep that in mind that you can't just quit if you think it's all going to cancel. You want to check to see, this is a side note over here, you want to check to see if it's going to be true or false. Okay, so let's try number 11. Cell phone company charges A charges $25 a month and 50 cents for each text. Company B charges $20 a month plus 65. How many text messages will give them the same? Okay, so let's try cell phone company A. $25 a month plus, okay, 25 plus 50 cents for each text. Okay, remember that every time you see that, that's the number that gets your variable. Okay, and then cell phone company B was $20 a month plus 65 cents for each text. And the question is, when will they cost the same? So let's set those equal to each other and solve. All right, let's get our x's together. So maybe subtract 0.5x. So I'll get 25 equals 20 plus 0.15x. Then I'll subtract 20. So I'll get 5 to equal 0.15x. Divide by 0.15. So I should get x to equal 33 1/3 text messages. Okay, awesome. Let's try some graphing, your favorite. Okay, so let's try 12. Again, these are not written like you like them in slope-intercept form, but they're really not that bad. Just make yourselves an XY chart. Plug in 0 for x, that gives me 2y equals -6, so that'd be -3. Plug in 0 for y, and then x would have to be -2. When you are doing the XY chart, you pretend that these are equal signs. Okay, you pretend that those are equal signs just for the time being. Okay, so I'll graph 0, -3, and -2, 0. It's just a less than, so that makes that a dotted line. Okay, and then I need to know which way to shade. Remember, we tested a point and we plugged in 0, 0. So right here I get 0 plus 0 less than -6. Well, is 0 less than -6? No. Okay, so 0, 0 is right here. So that is a false statement, and I always shade true, which means I'm going to shade away from that. Okay, so let's try our second equation here. Same idea. I'll make an XY chart. 0 in for x means that y would equal -4. 0 in for y means that x would equal 2. Okay, I gotta erase those equals. Okay, so now I've got 0, -4, 1, 2, 3, 4, and 2, 0. And a less than or equal to makes this a solid line. Okay, and if I test 0, 0, I get 0 minus 0 less than or equal to 4. That is a true statement. Here's 0, 0. So this time I have to shade towards that. So our overlap is this area over here. Okay, excellent. So 13 just has 3 lines. Yippee! Are you laughing? You should be. Math is fun. Okay, so I'll do an XY chart again. So I would get 0 and 2 and 5 and 0. Okay, so 0, 2, 5, 0. That's a less than or equal to, so that's a solid line. If I test 0, 0, I'm going to get 0 plus 0 less than or equal to 10. That is true, so I'm going to shade towards 0, 0. Oh, good. The second one is in slope-intercept form. That's the way you like it. So you always start up at 2. So up at 2, slope of 3 is up 3 over 1. That is a dotted line. Okay, again, you're still going to test 0, 0. So here you get 0 greater than 0 plus 2. Well, that is false because 0 is not bigger than -2. So this time I shade away from 0, 0. And then x is a vertical line. So at -5, I'll have a solid vertical line. Vertical lines are pretty easy to tell. Greater than should be to the right. So my overlap is below the pink, to the left of the purple, and to the right of the blue. So it'll be this triangle area in here. Okay, very good. Let's try some more. 14, so x we just said is a vertical line at 4. Again, this one's a solid one because it's got the less than or equal to. And so that's going to be to the left because that's where less than that is. Y greater than 0 is horizontal. So y, and then that's a dotted line. And then that needs to be above because we said greater than 0. And the third one is in slope-intercept form. So we start up at 1. A slope of -2/3 is down 2 to the right 3. That is also a dotted line because it's just less than. I might test 0, 0 here. 0 greater than 0 plus 1. Well, 0 is not bigger than 1, so that's false. So I'm going to shade away. So now I need to be above the pink, above the purple, and to the left of the blue. So that's going to be over here. Okay, up in that middle triangle-ish section, but do not go down here. That's a no-no down here. Don't go down there. Maybe I shouldn't have done that color. Not down here because you have to be below the pink or above the pink. Okay. All right, and 15, last one for chapter 5. Write the system that represents the graph. So working backwards is always hard. So let's try this first graph up here. Okay, and we're good at slope-intercept form. So we know the y-intercept is 3. Okay, so I've got a y and I've got a +3. Then I see this other point over here. So it'd be down 2 and 1, 2, 3, 4, 5 over. So that'd be a slope of -2 over 5 x. Okay, and I know it's going to be a something or equal to because it's a solid line. Now I have to figure out if it's less than or greater than. Well, because 0, 0 is shaded, I know I need a true statement. So is 0 bigger or less than 3? It is less than, so it's a less than or equal to. Again, you could just test yourself, 0 less than or equal to 0 plus 3. That's true. It was shaded that way, so that should make sense. Okay, and let's try the second line. So y-intercept here is a -3. And then another point here would be right about there. So I'm up 1 over 2, it looks like. So a slope of a half. And this is not going to be an equal to because it's a dashed. And I'm shaded above it this time. So 0 needs to be bigger than 0 minus 3. So greater than looks good. Okay, and there's your system. Now on the exam, they may not give it to you in that form. They may give it to you in standard form. But from here, you should be pretty good at doing that. Okay, we'll just practice with one of these. So if this second equation had to be in standard form, I'd subtract my 1/2 x, and then I would have to multiply by -2. So that would give me x minus 2y and a 6. The only thing you have to remember is that when you multiply by a negative, your sign would flip. Okay, so your answer is fine. Do it the way you're comfortable with, and then if the exam makes you do it in standard form, wink, wink, nudge, nudge, you might need to be really familiar with this, then go ahead and flip your sign when you multiply by a negative. And that's the end of chapter 5. Nicely done.